need to restrict access to specific tools without rewriting your entire authentication system. You'll see how to create targeted middleware that blocks sensitive operations like delete or admin config tools while letting other requests pass through unchanged. The pattern uses FastMCP's middleware hooks to inspect tool names and raise access errors before execution even begins.
From FastMCP server middleware, import middleware. Middleware context. From FastMCP exceptions, import tool error. Class auth middleware. Middleware. Async def on call tool. Self context. Middleware context, call next. Tool name, context message name. Hash deny access to restricted tools. If tool name lower. In delete, admin config. Raise tool error. Access denied. Tool requires admin privileges. Hash allow other tools to proceed. Return await call next. Context.
This demonstrates the middleware pipeline pattern for cross-cutting concerns in RPC systems. The concept treats middleware as a chain of interceptors that wrap core operations, allowing you to inject behavior like authentication, logging, or validation without modifying the underlying tools or resources. What makes this distinctive is its non-invasive nature. You add functionality by composition rather than inheritance or direct modification. The pattern works by creating a layered processing pipeline where each middleware can inspect, modify, or reject requests before they reach the target operation. Each layer in the chain receives the request context and a continuation function, deciding whether to proceed, transform the request, or short-circuit with an error. This creates a clean separation between domain logic and infrastructure concerns, with middleware handling orthogonal features like security or monitoring, while your tools remain focused on their core functionality. This approach solves the problem of scattered cross-cutting logic in distributed systems. Instead of duplicating authentication checks in every tool or mixing logging code with business logic, you centralize these concerns in reusable middleware components. The trade-off is a slight increase in conceptual complexity, but the benefit is dramatically cleaner tool implementations and consistent behavior across all operations. It's particularly valuable in RPC systems, where you need to enforce policies uniformly across many endpoints. Let's break it down line by line.
From FastMCP server middleware, import middleware. Middleware context.
Imports the base, middleware, class, and its context type. This is FastMCP's middleware pattern for intercepting and modifying tool calls before they execute.
From FastMCP exceptions, import tool error.
Imports tool error, the custom exception class for tool-specific failures. This enables consistent error handling when tools reject requests, like the access denial in this middleware.
Class auth middleware. Middleware.
This defines auth middleware, a FastMCP middleware class that intercepts tool calls. Middleware pattern lets you inject cross-cutting concerns like authentication before tools execute. It inherits from FastMCP's base, middleware class to hook into the call pipeline.
Async def on call tool. Self context. Middleware context, call next.
This defines the middleware hook for tool calls. The on-call tool method intercepts every AI tool invocation, receiving the execution context and a call next delegate to continue the chain. This is FastMCP's middleware pattern for pre-post-processing tool calls.
Tool name, context message name.
This extracts the tool name from the incoming message context. The context message name property identifies which AI callable tool was requested, enabling the middleware to apply access control rules before execution.
Hash deny access to restricted tools. If tool name lower, in delete, admin config.
This implements a security check using a restricted tools list. By converting the tool name to lowercase and checking against known admin-only operations, it enforces access control before any tool execution. The pattern prevents privilege escalation by explicitly denying dangerous operations early in the middleware chain.
Raise tool error. Access denied. Tool requires admin privileges.
This raises a tool error to immediately block unauthorized access. It enforces security by denying execution of restricted tools like delete or admin config, preventing privilege escalation before the operation even begins. This is the standard FastMCP pattern for tool-level authorization.
Hash allow other tools to proceed. Return await call next context.
This invokes the next middleware in the chain, allowing the tool call to proceed. Without this, the middleware would terminate the request pipeline. It's the explicit continuation pattern in FastMCP's middleware stack. FastMCP execution control. The middleware pattern in FastMCP2 intercepts tool calls before execution, enabling runtime authorization, argument modification, and result transformation through the on-call tool hook. Raising tool error is mandatory for denial scenarios. Returning other values breaks the error propagation chain and may expose restricted functionality. This pattern creates invisible gates that protect your system while remaining transparent to valid clients.
The middleware that stands between everything belongs to nothing.